Hi guys, this is Amit and welcome to another video. This is basically the second part of understanding Dijkstra's algorithm. So in my previous video, I explained how the algorithm works and how it is able to find out the most optimal route between the source node and the destination node. And in this video, I'm gonna talk about like how you can actually write it out on Python, or rather like how you can actually build up the logic to understand what you're supposed to do next. So yeah, let's get started. So in my previous video I did the simulation on this graph. So the first thing that we need to do is we need to be able to represent this graph in our code. So the way we do it is using dictionaries, something called dictionaries. So if you don't know what dictionaries in Python are like list, except that you don't access the values using index, you do it using keys. Let me just show you what I mean by that. So for example, here's the graph, here's the dictionary, and for each node, you have all the child nodes with the cost involved to take that path. So for example, if I just have to run the code, let me just show you like what I mean by accessing the keys. So if I say like graph, and then if I just say a, it is basically going to give us all the child nodes, right? So you get the point, right? So let me just clear the console. And then what we want to do is we want to maybe create a function. We can call it Dijkstra, and then as the parameters we want to pass in the graph, and because of course we need to work on the tree, and then we want to pass another node as the start node, and then the other node as the goal node, right? Pretty much self-explanatory. And then we want to create some empty dictionaries for different purposes. I'm going to walk you through as I write them. So the first dictionary is called the shortest dictionary, which is shortest distance, not dictionary, and which is basically going to store in the the minimum cost to reach to a particular path. So if I say shortest distance and then shortest distance of a, if I say shortest distance of a, I want it to be able to store in the minimum cost of a, right? So that is the main purpose. So if I have to just just write a comment, so it is basically going to records the cost to reach to that node, right? Which is basically going to be updated as we move along the graph. Okay. And then the next dictionary is going to be something called track predecessor, which is basically going to keep track of the node that had been previously visited before reaching that particular node, so that we can keep track of the path, right? So this is basically going to basically going to keep track of the path that has led us to this node, to that node, right? Basically. And then what we want to do is we're going to say unseen nodes and pass in the graph, because we're going to work with unseen nodes. What we want to do is we want to be able to iterate through all of the nodes, so that we have actually explored all the possible paths that we can take and all the cost that is involved, so that we can make sure that we have not missed the optimal route to the goal node, right? So yeah, this is why we need to be able to iterate through all of the nodes, right? So we're gonna say like to iterate through the entire graph. Okay, cool. And then what we want to do is we want to assign infinity. Infinity is basically going to be a very large number, right? This is going to be a very large number. Yeah, just make sure that it is significantly greater than the cumulative cost of all the edges that you're working on, right? So infinity can basically be considered a very large number, right? Okay, cool. And then what we want to do is we want to create an empty list, which is going to, like, after we have reached the end, after we have reached the goal node, we want to be able to trace back our journey to see that what is has been the path that has led us to this particular node, right? So that we can actually find the optimal route. So going to this is basically going to trace our journey back to the source node, which is basically the optimal route. Okay, so far so good. And now what we're going to do is, the first thing that we have to do is, we remember how initially we assign the cost to reach the source node as 0, and how we assign the cost to reach all other nodes as infinity. If you don't remember, just like go through my previous video again, so that you understand like how Dijkstra's algorithm works. So initially what we do is, we assign infinity to reach we assign 0 as the cost to reach to the source node, because we are starting out from the source node, so there is no cost involved. And since we are just starting out, we don't know if there are any possible paths to all other nodes, so we assign infinity to all other nodes. We assign infinity to the cost to reach to all other nodes, right? So what we're going to do is, we're going to write a simple for loop. We're going to say like for node in unseen nodes, what we want to do is, we want to say shortest distance of the nodes. We want all the cost to reach all the nodes to be infinity, except the shortest distance of the start node, because that is going to be 0, because we're just starting out from the start node. Fair enough. And then what we're going to do is, we want to actually iterate through the entire graph. So what we're going to do is, we're going to say like while we're going to say like while unseen nodes, right? And this will allow us to if you know how Python works, you would understand that this basically means that it is going to run until until there are any nodes in the dictionary left. It is going to run until the entire dictionary is empty, right? This is going to make sure, help us ensure that we have actually seen all the nodes, and we have actually explored all the optimal paths. So yeah, and then what we want to do is, we have to let me just write it out, and then I'm going to explain. So if we're going to say like if just like initially we're going to say like main distance node to be none. Initially there is not going to be any mean distance node, right? But then for node in unseen nodes, if mean distance node is none, which actually is, we want to say the mean distance node to be the starting node. And then else if, what do you want? We want, which is the main part, which is like if the shortest distance of the node is lower than the shortest distance of the mean distance node, then what we want to do, we want to actually swap the value of the mean distance node. Like very simple logic. I'm just going to explain. Okay, now that I've written, I'm going to explain what this is. So we need to be able to traverse through the graph. So every time we need to determine what is the mean distance node. And the way we do it is, we're going to say like if the shortest distance of the mean distance node is lower than the shortest distance to reach to that particular node is, if it is lower, then only I'm going to replace, so that so that I move the pointer forward, so that I can move the pointer forward if the shortest distance is lower, which will help us determine the lower cost, right? So yeah, this is basically what it means. And then what we're going to do is, we want to be able to check what are the options that we have from the mean distance node, right? So once we have figured out the pointer, so for example, this will only ensure that what is the pointer, but we still need to figure out how do we make sure that the shortest distance is lower. We will code it out later on. So first of all, this is going to ensure that if you find out that the shortest distance is lower, then just move on the pointer so that we can move forward through the graph. This is basically what it says. Okay, so now what we need to do is we will need to be able to find out what are the paths that we can take from the mean distance node, right? What are the options that we have? So let me just show you something before I write it out. So if I say like graph A, and then if I just say like items, this is basically going to give us all the child nodes with all the costs involved, right? This is basically the paths that we can take, right? So we're gonna say like path options is basically what we have like graph, and from the mean distance node what I want to do is I want to say like items, which is basically each time we have figured out the mean distance node, we want to find out what are the possible paths that we can take from the mean distance node. I hope that makes sense. And then now is the like all that we have done so far is like the calm before the storm, basically. Now we have to actually write the central the integral part of the algorithm, which is basically telling us like when is that we are supposed to update the cost of a particular node, right? Sorry. So we're going to say like for child node, and then wait in path options, what we want. So what we're going to say like if the summation of the weight and the shortest distance to reach the mean distance node, if it is lower than the shortest distance to reach the child node, then what does it mean? We have actually established a more efficient route. If it is greater, then you have what you have already found is a very optimal route, right? You have already found a very efficient route. But if I found another route which leads to a lower cost to reach to that particular node, then I have established a more efficient route. Then you are supposed to update the cost, right? So we're gonna say like shortest distance of the child node is going to be updated, of course, because that is the only thing that makes sense, which is basically going to be the summation of the weight and the shortest distance of the mean distance node. And while we are at it, we also want to be able to track the path that is leading us to that particular node. So we're going to say like track predecessor of the child node is basically going to be the mean distance node, because from the mean distance node we have actually gone on to the child node, right? So the mean distance node is the predecessor, and this will also be stored in the track predecessor, and this is going to help us figure out the path that has led us to the particular node, and ultimately going to help us to trace back our journey. And then what we want to do is okay, just let me just get out of the for loop. Okay, I hope it's correct. Okay, so now what we're gonna do is we want to pop out each of the nodes after we have worked with them, so that we don't keep on iterating over them again and again. It is never going to since we have written like while unseen nodes, it's going to keep on running until we have exhausted the list. So the only way we can make sure that we ultimately reach an end is by popping out the nodes after we have worked with them. So we're going to say like unseen nodes dot pop, and we're going to pop out the mean distance node. And also because Dijkstra's algorithm does not allow for backtracking, so we won't be able to find out we won't iterate through the nodes that have already been visited, right? And then what we want to do is just get out of unseen nodes, right? Because we are done with it. Okay, Cool. Now what we want to do is we want to say a few things. We want to trace back our journey. So we're gonna say like, considering that the current node is the goal node, considering that, and while we want to basically trace back our journey, right? So we're gonna say like, like just set the current node as the goal node, and then keep on doing until the current node is not equals to the start node. And the reason why I'm writing this, I'm going to explain that in a moment. We want you to be able to trace back until we have found the start node, because now we are going to keep track of the predecessor node. And the reason we said like not equals to start node, because the start node does not have a predecessor. So this is going to, whatever we are writing, this is going to apply for all the other nodes except the start node, right? So we're going to say, okay, so now we have worked with an example which like all the nodes is connected to all the nodes ultimately. And if you just like pass in a start node and if you pass in a goal node, you will ultimately find that out, because all the nodes are connected. But in a lot of cases what will happen is like you will find out that there is no path between from one node to the other node. So what will happen is or it's a directed graph basically. So what will happen is you will find that there can be instances when somebody creates a graph and then passes the start node and the destination node, and there is no actual path between them. So for that we need to create this unique case as our exception, right? So we're gonna say like try, and then what we're gonna say I except. So basically if there are no path error, this is basically going to give us the key error, right? So we're gonna say key error, and then what we're gonna do, if there is no path, oh man, okay, so if there is no path, we're gonna say print path is not reachable, and then we're just gonna break from the for loop. And however, if there is a path, then what we want to do, we want to track path. We want you to insert the current nodes. So current node, and then we want you to update the current node to the the track predecessor of the current node, because that is going to help you move backwards. So like for example, if the current node is updated to the predecessor node, and then the predecessor node is actually the current node, and then you update it to the predecessor node, and this will help you move backwards, right? Should make sense. And then we have done this for all the nodes except the start node, because the start node does not have the predecessor node. So we're going to say like for the start node, so the track path dot insert for the start node, we're gonna insert start node. Okay, cool. Now what we want to just click print, right? So we're gonna say like if shortest distance of the goal is not equals to infinity. And the reason we're writing this is like if the cost still remains infinity, it means that we have not reached a path, right? We have not reached a path to the end node. Yeah, so this is basically what it means. So like if it is not infinity, that means we have found a path. So we're gonna select print. Now just like user friendly message, shortest distance is, and then we're just gonna say like it is basically the cost is going to basically be stored in the shortest distance of the goal node, right? The shortest distance of the goal node basically stores the minimum cost to reach to the goal node, right? Makes sense. And then we're gonna say like path optimal path is, and then what we want you to print track path that has traced back our journey. right? So this is all about the algorithm. I am hoping it should work. I'm not sure, however, let me see if it works. Okay, so if I just run the code, it says unindent. Why? I made some indentation. Okay, so it's not here, it's there. For child node, it is just going to give a bunch of indentation errors, I feel. Unseen nodes dot pop. Yeah, okay, just bear with me, just skip to the part where I get it right. Start shortest distance is 0. It should be shortest distance. Where is it? Where is the goddamn thing? Shortest distance. There should be underscore, bro. Okay, run. Track path is not defined. It's not. It should be track path, not path. Okay, it works. Okay, just let me just run the code. Okay, so yeah, the shortest distance from A to H is 13. So let me see what is the optimal route. So they say A C D E H. A C D E H. They don't consider B because, you know. So for example, if you just see, like, for example, if you move from A to B, it's 3, and then from B to C it's 4, but you can just like move from A to C directly, right? It means the same thing. So like they have, like, the algorithm has, you know, figured out like the optimal cost to reach all of the nodes, and figure out that this is the most optimal route, and it has given the shortest cost, which is basically 13. We have seen in our previous video it is actually 13, right? So yeah, this is all about it. So guys, do let me know in the comments if these videos helped you. It took me a long time, basically it's like late in the night. And also do let me know in the comments, very importantly, you don't have to let me know if this video has helped you, but you should let me know if you are facing difficulty understanding a particular concept. Do let me know in the comments so that I can help you out with that. And thank you so much for watching. See you next time. Bye.